Okay,
Blue's
so
gonna be on top.
since we're not real sure, we're gonna use our calculator to graph these, yes, and yours graphed your first one as blue. What color's your second one, Jordan?
Red.
Oh, yeah, look, mine too. So does a region get enclosed by these two graphs?
Yeah.
Yeah, it does. Here you go, sorry about that. So a region does get enclosed. I'm gonna zoom into it so we can see it a little bit better. What am I gonna need to find about this region?
Find where they intersect.
Find where they intersect. Thank you for a good answer.
Both of them go through the origin.
So, yep, they definitely go through the origin. Should you check that just to make sure it's not like 0.01?
Well, it doesn't go through because when x equals 0 for both of them, then the whole function will equal 0.
That's what I meant by check it. So make sure that you're trying. If you think it's the origin, just plug in 0 and make sure you really do get 0. So yeah, 0 is definitely one of those intersection points. So they intersect at x equals 0, and can you find this other intersection point, please?
Oh, can you just do like stat calc find that intersection?
Do
You just do calc.
do second trace.
Yeah.
Oh, yeah, I did.
That's what you meant. You didn't mean statistics.
I was meaning something with the calculator, right?
Yeah, something around there. So do you get 1.18?
Yes.
Something in there.
Now, on the AP exam, they expect you to use the entire decimal. You are not supposed to round anything until you get to the final answer. So don't round this yet, because rounding that's going to affect everything else that we do. Okay? So at this point, we now need to just set up what our integration would be, correct? So our integration would go from 0. There you go. And which of these curves was the top curve?
X to the
Blue
4.
one.
Wasn't it the blue one, but not this x with the square root? So it's going to be this curve. Subtract the bottom curve, and wasn't the bottom curve the x to the 4th minus x? Now, since this is a calculator active question anyway, would we try to integrate this on paper? No, absolutely not. We're going to type this into our calculator and find the integral using our calculator. Yes, sir, Austin.
Would that subtraction sign?
Ooh, Austin, you have to have parentheses around that. Nice job. You get a bonus point for that. You've got to make sure you're subtracting the whole bottom function. So please make sure that you put parentheses around it. Or go ahead and distribute the negative. One or the other.
We're just doing the math 9.
So I would go to, you could do math 9, or you can hit alpha window. Either way, it's about the same number of keystrokes. Should be on a clear screen first.
These calculators can do definite intervals for us. Why do we even have to learn them? That's the real question.
Everybody in the room knows the answer to that question?
Computers are the future.
So do you get the same thing I got?
Yes.
All right, so at this point you would round your answer. And you can round to 3 or 4 decimal places as far as the AP board is concerned. So either one would be good. I would say 0.785. Well, hang on, let me see if this is the right answer, and then we'll see if you've done something wrong. Yeah, I got 0.785 every time I've done
Oh,
it. So. So do you see what you did?
yeah, I did my, what do you call it? My square root in the denominator of the first function. Yeah.
You good? Okay. All right, so let's look at the next example. Find the area of the region bounded by y equals sine of x, y equals cosine of x equals 0, and x equals pi over 2.
So,
Okay.
you're able to do these without calculator.
Yes.
Sine of that last one.
Oh wait, was that plus?
Yeah, they
They-
would,
they
they would
did-
not.
That didn't.
No, that last one was a completely calculator active question. They are not gonna ask, because you can't find that intersection point easily without a calculator.
Cause it's like 1.8.
And finding the intersection point with a calculator is something the AP board expects you to be able to do, and that they'll include in questions for you to do, so. If I did not give you these boundaries, how many regions are bounded by the sine curve and the cosine curve?
Well.
Infinite.
Oh, yeah, because it just keeps.
Right? Because the sine curve goes on forever and the cosine curve goes on forever, and so there are infinite amounts of regions that get bounded there. Let's draw our sine and cosine curves, remember?
So you're just drawing D and A?
Which one is this?
That's the sine curve.
This is the sine curve.
Thank you.
What is this x-intercept?
Pi over
Pi over
2.
two.
Mm.
2 pi.
Okay, what is one full rotation of sine? 2 pi. So then this is just pi.
And then, so pi over 2 is at kind of the top of.
So pi over 2 is going to be right over here at the top. And I'm going to go ahead and draw that as a boundary because I know it is one of them. X equals pi over 2 and also x equals 0. Okay, now to graph our cosine curve. And I'm going to highlight just so we can remember which one was which.
That would, like the middle is
Draw in my x and y axis too, so you don't get confused. Because my vertical line at pi over 2 is really big and almost looks like the y axis. So. All right, so what is the y-intercept for your cosine curve?
It's 1.
It's 1. And so doesn't it mean it goes from there, here, to here? So this blue curve is my cosine curve. So Austin, do you see when you look at this one that sometimes the blue curve is on top and sometimes the yellow curve is on top? So there's two different regions here.
Is that going to be pi over 4?
Yes. Is that intersection going to be pi over 4? What is cosine of pi over 4?
It's sine 45 degrees and sine 45.
Square root of 2 over 2. What is sine of pi over 4? Square root of 2 over 2.
I was going to intersect.
So don't they intersect right there at pi over 4?
Yeah, that's how I did that math.
Oh, yay.
I didn't look at the graph.
So we're going to have to set up two different integrals here because at different points we have different functions on top. So we're going to have to set up one integral that goes from 0 to pi over 4 with which function? Which function's on top for that one? That would be cosine of x minus sine of x. Please don't forget to put your dx there to denote what our variable is. And then plus, yep, Aaron, we go from pi over 4 to what? Pi over 2. And now which curve is on top? Sine curve minus cosine curve. Lucas, will you stop it here?
Yeah.